If an edge E joins A to B together, so A to B, we say that A and B are instant with E and E is instant with them. So E is the edge and it links A and B together, essentially. The degree of a node is the number of edges instant with it. So example would be A, B, C. And you can see that there's two nodes for A, or sorry, two edges for A, two edges for B, and two edges for C. Okay, it's also called fancy or order. Then we have the handshaking lemma, or lemma. The degree total of all the graph is double the number of edges in the graph. So if I go to my last example, see the way there's three edges, 1, 2, 3. Double that, you get 6, and 6 adds to all the valency of the nodes. And in our first example, if we double the edges, we get 2, and 2 adds up to the answer for all the nodes. So that's good to know. Now let's have a quick look at this. Write down the degree of each node. Well, A is going to be 1, B is going to be 2, C I think is going to be 3 because it has 1 here linking B, and then there's 1, 2, 3. 3 things coming out of C, and I think D will be 2. And what's the degree total? 1, that's 1 plus 2 plus 2 plus 3. Here we're going to get 8. How many edges are there? Well, 1 edge, 2 edge, 3 edge, 4 edge. 4 edges, and we can see that the degree total is double the amount of edges. Okay. Question 3. Write down the degree of each node of this simple graph. 2, 2, 2, 2, 2. They're all 2s. Add two edges to the graph so that this is the new table for the degrees. Wants A to have 4 and C to have 3 and D to have 3. So notice that B and E remain unchanged. So B and E are off limits. B and E aren't to be going here. So I think if I link A to C, that will send that up to 3. That's a 3, and obviously A to 3. But then if I link A to D, that will send D to 3. And obviously A to 4. So I think that's what I'm happy with. Happy days. AC and AD are added in. Good. This is question 3. Now, I have to make some further changes, okay? It wants me to make one further change so that this is the new degree. So A stays the same, B stays the same, C stays the same, and D stays the same. But E goes upwards. So think if I add if we add a loop at E, I think that will send it to. So loops actually add on 2. So what we're going to do is write the loop in, and that turns E in from 2 to 4. So is your graph simple? No, it's not simple because it has loops in it. Okay, happy days. Draw a graph of 4 nodes. So we'll go for A, B, C, and D. Draw one that has 2, 2, 2, 2. This one here has 2 edges incident on each vertex. So basically 2 lines coming out of each corner. And that's a 2, 2, 2, 2 one. And so that's question 1 done. Question 2, 2, 1, 1, 0. So D is going to be 0, A is 2, B is 1, C is 1. So I think I'll just do it like this. A to B, just that. Right? Done. Next one. 4, 3, 2, 1. So 4, 3, 2, and 1. Right, A to B, A to C, A to D. Now that might not work. That's only 3. So I think I'm going to have to loop A, do 2 of them, and then loop A around. So 2 plus 2 is 4. That's A with 4 done. B has 3. B has 3. So I could put B to D and then B to C, like so. Another way I could do it is I could put C to D and I could loop B, and that's the same answer. Okay. Now, so I did part 4 there. Part 5, 1, 1, 1, 1. Well, that's easy. Let's do A to B and D to C, and they're all 1s now. They're not a connected graph by any stretch of the imagination, but they're still all just 1s. I sort of skipped part 3 there, but that'd be grand. Why is it not possible for the degree 2, 1, 1? Why is it not possible for the degree to be 2, 1, 1, 1? Hence using handshake and lemma. All right. So 2, 1, 1, 1. So A is 2, B is 1, C is 1, D is 1. It's an odd number, so it'd be 5. Okay, so it'd be degree 5. And if you divide it by 2, you can't have 2.5 edges. It has to be even number of, the degree has to be even, and it has to divide by 2 to give you 3 edges. So it can't be an odd number of odd power or odd degree. All right. Question 5. Yep. The one is value. The rest of these are synonyms. Basically, the rest of them mean, like example A, 3. You can say its valency is 3, its degree is 3, or its order 3 if it has 3 lines coming out of it. Pedro says the sum of all degrees of the nodes graph will always be even number. Is he right? Yes. Because number of edges equals degree divided by 2. Degree total degree, or degree total divided by 2. And edges has to be a natural number. Be a natural number. Reason being, you can't have 2.5 edges. You have to have 2 or 3 edges. The number of nodes with odd degree cannot be odd. Is she right? Explain. Number of nodes with odd degree cannot be odd. So, an example, this is true, but let me explain what's true. So imagine 3 sides, A, B, and C, right? And A is odd, B is odd, and C is even. Because there's an even number of nodes with odd degree, the answer is a total degree of 8. And because the total degree has to be even, in any other case where you'd have like A, B, C, D, and E, imagine you have just A and B are still like 3 and 3, and then C is 5. That will add to an odd number, even if the other 2 are even. Okay, but if there's a number of nodes with odd degree, cannot be odd, because if they are odd, the total degree will be odd, which means the number of edges won't divide equally into it. So therefore, she's true.